Assalamualaikum warahmatullahi ta'ala wabarakatuh and good day to each and everyone. Okay. So congrats, no? Nandito na tayo sa week 3, okay? So um no, I assume that after nyong mabasa, okay, yung week 1 and week 2 natin at the same time um watching our video, no, even if it is only an overview about that topics. I assume that you have already your own idea about these topics, okay? So sana naintindihan natin lahat, since wala naman tayong, konti lang naman yung nag-ask, so sana naintindihan natin. Okay, so once again, congrats, since you have already done itong week 1 natin and week 2 natin, and now you are here in our week 3. Okay, so yun. So once again, this is introduction of environmental engineering. Okay, once again, our topic again is mass and energy transfer. Okay, now, so as I have said from our week 1, okay, environmental engineering uh, is about uh, is about an environment, or about an energy of the environment surroundings us. Okay, so therefore, no, in here we will talk about the energy fundamentals, no. So again, we can also use this one to study the different parameters or important parameters related sa ating environmental engineering. Okay, okay, so energy fundamentals. Okay, so the first energy that we can use, or ang pinaka core idea about these energy fundamentals, is yung natakal natin sa ME52, which is the thermodynamics law. Okay, so yun, the thermodynamics law. So alam natin na yung thermodynamics law is meron tayong first law, second law, and third law, but ang pinaka importante dito is actually the first law of thermodynamics, kasi yun kasi yung always na ina-apply dito sa environmental engineering. Okay, so we can use the first law of thermodynamics to write energy balance equation that will help us analyze energy flows, no. So as we can discuss in our week 3, week 2, meron tayong flow of energy with regards to our energy balances. Okay, so yun, so it's either wala tayong accumulation rate or wala tayong reaction rate, okay, sa system natin. So same pa rin, applicable pa rin dyan yung first law of thermodynamics natin, which is an energy balance equation. So sorry for if you have sorry for intervention, no, sounds na naririnig ninyo. Okay, kasi di natin ma-restrict yung environment natin, or yung mga tao rito, okay, from us. Okay, so anyway, hindi naman masyadong naririnig sila. Okay, so sorry for that. Okay, now again, no, since we are talking about here the laws of thermodynamics, which is the first law, particular the first law of thermodynamics and the second law of thermodynamics, we need actually the conversion from energy to heat, no, since usually heat yung ginagamit natin dito. So 1 joule per second is equals to 1 watt, or it is equals to 3.412 BTU per hour. Okay, so what is the first law of thermodynamics? The first law of thermodynamics says that the energy can neither be created nor destroyed. So same to siya doon sa idea natin kanina sa week 2, na yung energy natin is, or kung i-apply natin the first law of thermodynamics doon sa week 2 natin, so wala tayong reaction sa loob ng system, kasi nga our energy cannot be created, hindi siya naka-create, hindi rin siya na-destroyed. So it is just a property of a certain substance Okay? Na pwedeng i-transfer from itself or from that particular substance to another substance. Okay? So, yun yung idea rito. Okay? Ito yung equation naman natin dito, no, developing the equation that we have learned from our week 2. Meron tayong equation na total energy crossing boundary as a heat or work plus total energy of mass entering the system minus the total energy of mass leaving is equals to the net charge of energy in the system. So, take note that yung sa week 2 natin, hindi yun siya energy, no? Hindi yun siya energy. Kaya, doon meron tayong accumulation at saka meron tayong reaction, no? Doon kasi sa week 2 we are talking about mass and volume. Dito is we are talking about energy. Kaya iba yung term natin dito. So yung term natin dito is yung net charge of energy in the system at saka yung total energy crossing the boundary. Okay? So yun. So another equation that is very important is itong energy natin, no? Ito yung tinatawag nating energy anong tawag dito, conversion uh, or mechanical to uh, wait lang, uh, I cannot remember what is the name of this equation, but this is actually a very important equation that we can use in our environmental engineering, no? So it talks about the total energy of the system is equal to the internal energy, no, inside that system plus the kinetic energy, no, kung meron tayong flowing na nangyayari sa loob ng system plus the potential energy kung meron tayong potential energy na involved sa system natin. For example, kung siya ay naka-elevated, so meron siyang potential energy, no? So kung isasum up natin yung tatlong energy na yan, that is equal to energy. Okay? So yun. Another one is itong enthalpy, enthalpy equation. So we have here H is equals to U plus PV. So H is also an important application of thermodynamics, no, or enthalpy, kasi it talks about the reaction of a system, or the transfer of energy of the system for constant pressure. Okay? So if yung system mo is hindi siya wala siyang or constant lang yung pressure na pero nag-gain pa rin siya ng energy, so applicable sa kanya itong si enthalpy is equals to internal energy plus PV. Okay? So and then meron din tayong internal energy which is equals to MCV change of T. Okay? Where CV is the proportionality constant or the specific constant of the internal energy if the system is in constant volume. Okay? So yun. So usually itong mga energies na to is only applicable for gases, no? So take note that this is only applicable for gases. Hindi natin to siya pwedeng i-apply sa liquid at saka solid. Okay? So yun. So table 3, specific heat capacity of a selected substances, no? So yung air natin is yun siya, yun. So as you can see here, yung water natin is liquid. So itong actually, no, okay. So yun. So meron tayong equation 50, no? So hindi ko pa pala muna i-discuss itong table 3. So sa equation 50 naman natin is change of enthalpy is equals to MCP change of T, no? So kanina, 'di ba sinabi ko kung constant yung pressure natin, meron tayong enthalpy. So that's why this is defined by this equation na change of H natin is equals to MCP change of T. Okay? Okay? So yan. So once again, this equation number 49 and equation number 50 is only applicable for gases. Okay? Kasi for liquid and solid, iba naman yung equation natin, no? So you have MC change of T. Bakit? Kasi yung C natin for liquid is different for every liquids, no? So magkaiba yung C ni aluminum, magkaiba yung C ni water, magkaiba yung C, iba yung C ni oil, no? So magkaiba lahat. Kaya in here ang equation natin for solid and liquid is MC change of T. So yung value ng C natin or specific heat natin is illustrated here sa table 3 natin. So you may just have to refer on that table para makuha yung mga value ng specific heat natin. Okay? So example natin is ito siya. So madali lang naman yun siya. So basahin na lang natin. So once again, no, if you have any question about our this topic, you may just have to ask it to me directly. Okay? So yun, assalamu alaikum warahmatullahi ta'ala wabarakatuh.